My name is Dmitry Dorogoy and I'm a C# developer. And now I want to talk about domain-specific languages, DSL. So, our current topic is DSL, domain-specific language. Another word, language specifically designed for a very close scope. Unlike the most general-purpose programming languages that are familiar to all, specialized languages has a very narrow focus. Let's start from a simple example. Databases. Structured Query Language, SQL. SQL is a structured query language specifically designed for querying databases and for manipulation with the data. It's not a general-purpose language. It's language only for databases. Workflow as DSL. Often, the desire to create a specific tool for a specific area results in the construction of a graphical editor to indicate connections and relationships. In many cases, this approach is very good, but not in all cases. Sometimes the desire to add a little graphics to something very similar to the general-purpose language begins to compete with the common sense. Notice how much more complex the definition of a simple condition has become. If you decide to implement DSL in your project, it must be profitable. In other words, do not do graphical DSL only because others do it. In case shown, the graphical representation is a complete disaster. It not only makes a mess, but it consumes more space than the direct English condition, if then else. The graphical representation for DSL not always a bad idea, but remember the goal of this representation. One of possible goals is simple representation for complicated things. Have you ever seen a wall near the database developer? What is on that wall? A database diagram. And database developer could always remember where client's database table is located. Developer used his visual memory and imagination to visualize a huge database structure. And in this case, graphical representation is a very good idea. But one simple thought. What happened if you rearrange tables on this database diagram and put it back on the wall? Try to think about it. But in some cases, visualization can be useful. For example, to show high-level diagrams or algorithm block schemes. Another very good example of DSL is graphical and text combined DSL. It looks like a visual sugar, but I think it's more than just a sugar. This algorithm representation changed the way of thinking about algorithm. Try to imagine this example without images. Is it the same DSL? I suppose no. Often, DSL is not just a language, but a language tied to a specific development environment. For example, it is very convenient to use a programming language to debug electrical circuits with hints about the pin assignment. But does the diagram in the middle make the language clearer than the text? And next discussion point. What do you think about complexity? Is it easy to support both text and graphical representation than only one of them? And what about equivalence? Is it always possible to represent graphically any program text, and vice versa? Speaking about different DSL representations, it is impossible not to mention the need to transform between representations, and some development environments provide this function. Usually, this is only a one-way road. Maybe many of you remember HTML file and a browser window. This is a very good example of one-way transformation between text and graphical representation. A very good example of DSL is the language of graph description. Just look at this. dgraph, G is a graph name, hello, error, world. It's all representation of simple graph hello and error world. Simple and easy to use. Don't think it's a very primitive language. At due diligence, it will be a very powerful tool. Just look at the screen. Let's make a little checkpoints and discuss cons and pros. Pros. DSL has a very close focus on a domain area. You can use your own abstractions, specialized syntax, maybe just a jargon words. Tweaked error handling. For example, sometimes error in general purpose language is not the same as error in your own DSL. Maybe sometimes you treat error as a normal situation. And of course, specific tools. Specific tools could be very close to domain area and very useful for people who work with it. Cons. Lack of support for common things, such as math expressions. We need to study it, our DSL. And the bad thing. No one wants to study bad design DSL. Now I want you to focus on a support for common things. I named this slide DSL Micro. This is a screenshot of a very popular graphic editor, CorelDRAW. Note how easy it is to divide page size by 2. This is the same as fold the paper sheet or add 10 mm to a page border. It is sometimes needed for magazine prepress operations. You also could easily transform between different units of measurement and do simple mathematical operations. And yes, it is a small but a very powerful and useful DSL. Now it's time to speak about internal DSL, also known as an embedded DSL. An internal DSL is a DSL based on a general-purpose programming language. In fact, it is just a very well-designed library, which hides language-specific details and shows domain-specific objects and functions to the user. It's not a 100% accurate description, but for now it's okay. Let's take an example of how you can implement a small piece of an internal DSL. As an example, let's take a graph description language. For making our simple internal DSL, we'll use a builder pattern. Let's describe the classes in our subject area. Vertex. It'll be described only with label just for simplicity. Graph edges. We assume that our graph is oriented, so we describe edges as from and to vertex and edge style. For simplicity, we treat style just as a string. Now let's apply the popular builder pattern. In our case, it fits just perfect. For those who are not familiar with the pattern, pay attention to class return types. I used two approaches here to demonstrate both. In the first case, the class returns itself, and in the second case, the class returns another builder class. The second builder contains the edge creation features, and the latest function sets the edge style and returns the previous builder. This function could be split into two. One sets the style, and the other completes the edge creation and returns the previous builder. As a result, we created a graph using syntax specifically focused on a graph creation. Let's review graph creation syntax. You could hardly find C# here. It looks like a very special graph creation language. Of course, we see a typical C# function chain syntax. But imagine, show this to a scholar geometry teacher. I expect everything will be understandable. It's all good, but it was an internal DSL. Of course, this syntax is nice to use, and now you could create any graphs with a simple builder syntax. Next goal is search through the graph. In other words, let's try to give users a function to search through the already created graph without digging into C# programming environment. And now you can do a simple but very spectacular trick. Note, we just switch a target goal, just for a demo. Similar trick could be used for a graph creation too. For this trick, first we need a system link dynamic NuGet package. And now, look how we could use an internal and external DSL side by side. In the first example, we filter vertices by key, which contains the letter E. Our graph class contains vertices dictionary, so we use key. It's easy to get rid of this variable name just by exposing a vertices collection with a specifically designed property. And look at the second example. We simulate user input as the user input variable, and this variable contains exactly the same expression we used in the first code part. And final action. We compare these two approaches results and get exactly the same vertices. At that moment, I am very close to my presentation goal. If you are dreaming about giving your users the ability to write some queries by themselves, just try to give them MVP, minimal valuable product. I showed you how easily it could be done. My solution is not for public and production, but it's very fast and simple for in-house implementation and for research. You should not dive into external DSL implementation without a very detailed research. In case you start thinking about SQL injection or something similar, the mentioned LinkU dynamic library gives you a solution with passing parameters into query as parameters and not as part of strings. If you are interested, just take a look. And now you are ready to hear a truth about a big, real DSL. It's really complicated, it's true. And at the same time, it's very interesting. Just for example, take a look at the screenshot. You can see a C# based library with a beautiful name Irony. And at the left window, you can see a simple C# program. At the right window, you can find a passing tree for this program. It seems big, but if you carefully look through line by line, you will find it easy to understand. At the first sight, it's a bit verbose, but it only depends on the grammar complexity and variability. Your own grammar may look more simple. My presentation's goal is not to dive deep into real grammars and parsers. I just want to inspire you to look at DSL and try. Now it's time to show you a real and sophisticated DSL sample. This sample is a visual regular expression editor with BLACKJACK and own regular expression syntax. Let me explain the initial requirements. First of all, we need to test regular expressions against a list of samples, both positive and negative samples. We might want to extend the samples by some expressions just for exploration without marking them as positive or negative. Second, we need building blocks. for composing complex regular expressions, and we would like to test those building blocks separately. Let me describe a regular expression part syntax. It is a declaration with name and a regular expression text. Note that I use a free-form expression format what allows me to arrange regular expression by lines and provide commands for separate lines if needed. On the side I declare two building blocks. The first is for number, name it, try to guess number, and the second one is for event, name having two forms. Short form dev day or long form developer day. At this morning I have only building blocks. My next step is compose a whole regular expression. Just for a simple demonstration, I suppose that we want to match number and event name, or name and a number. Pay your attention at the screenshot. It looks quite simple and readable. At this moment, my regular expression syntax is more powerful than many others. But where is BLACKJACK? Now it's time to add a syntax for testing a regular expression. A good example of syntax extension is embedding test into the syntax. The accept keyword is for text that must be matched, reject for text that should not be matched, and a sample for text we just want to track for curiosity. It looks like a real BLACKJACK. And now it's time for another BLACKJACK. We want more than just to see our test status. We also want to see the exact matched text. Cool? If not, we can see a predicted execution time and the complexity of the resulted regular expression. By the way, there can be some pathological regular expressions that perform very slowly and with a significant memory consumption. And the difference between normal and pathological regular expression may be just with one symbol. So it's important to not only know the matching status but also the matching speed. Speed? You should know how I measure the matching speed only for short samples. It's useful for edge cases. But what about a normal flow? It's my DSL, and I can improve it. Testing speed of the short samples is a good idea, but we can do even better. I've added a testing against some typical patterns: English text, numbers for spreadsheet simulation, mixed text and numbers, and something close to random binary file. So now it's all for today. I hope now you want more about what is DSL and how it could be done, and how easily it could be done just for test. I hope you want to test and implement DSL in your project. In any case, you could contact me by any social network. See you. Bye.